AP Cram, Calculus AB, Free Response Exam Review, Question 56, Midpoint Sum. Alright, so hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t is either greater than or equivalent to 0 minutes, or t is less than or equivalent to 6 minutes, is given by the differentiable function c. I meant a differentiable function, okay, where t is measured in minutes. Selected values of c of t, as shown here, measured ounces, are given in the table above. So what we have to do is use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1/6 times the integral from 0 to 6 minutes of ct dt, and using the correct units, explain the meaning of 1/6 the integral from 0 to 6 ct dt in the context of the problem. I mean, this might seem a little daunting, but essentially the question stem kind of solves the entire problem for you. So some people realize what's going on immediately and some don't. Okay, and that's completely fine, because the first time I saw this, I was like, whoa. So I'll give you a moment to think about your strategy. Okay, so the first thing that you have to realize is that we're asked for a midpoint sum of 3 subintervals of equal length. And we know that our interval is from 0 to 6 minutes. So if we have to divide this into 3 subunits of equal length, that's very convenient, because 6 divided by 3 is 2. So each subinterval will have to be 2 subunits. So 0 to 2, 2 to 4, and 4 to 6. Okay, but we have to take the midpoints. So we're looking at a midpoint of 1 in the first interval between 0 and 2, a midpoint of 3 in the second interval, and a midpoint of 5 in the third. Okay, and again, the reason why we're doing this is because we're using the data in the table to approximate the value. All right, so this was the most tricky part to basically comprehend. And when all is said and done, after we finish our calculation, you need to just know that we're making rectangles, obviously, because we have a height, which is c of t, represented by these values, and we're eventually going to multiply that by a width. So these rectangles, the summation of these rectangles basically represents an approximation for the integral from 0 to 6, but dividing them by 6 represents an average amount of ounces of coffee. Okay, so I've been rambling on for enough. Let's just get right into it. So we have our integral 1/6 from 0 to 6 minutes of ct dt, and that is approximately equal to 1/6. But this is what's our approximation for ct dt inside our integral, 2 times c1, because remember, we divided our interval into 3 equal subunits, so they're each going to be multiplied by 2, plus 2 times c3 plus 2 times c5. So we're summating the values found at our midpoints times our width of 2, okay, and we have 3 subintervals. So we fulfilled all the requisites, denoted in our question stem. Therefore, we have 2 times C1, which is 5.3 ounces, plus 2 times C of 3 minutes, which is 2 times 11 ounces, plus 2 times 13.8 ounces, which is C of 5. All right, and when we add that up, we get 1/6 times 60.6 ounces. When you divide this, you obviously get 10.1 ounces. So there's an average amount of coffee in the cup from 0 to 6